Hey Pre-Calc students, welcome to today's lesson on solving systems of conics algebraically. We're also going to be solving systems of conics graphically in the next couple days, okay? So just so you know, quick reminder that a system means that there's more than one equation that you're working with, okay? So um, if you take a look at example one, you've got two equations, right? You've got y equals x squared plus 8x plus 9. That's a quadratic. The highest exponent is 2. And then you've got another one that says y minus x equals 3. So that's a linear equation because the highest exponent for the x is a 1. So if you remember back to the pre-lesson that you worked on previously, when you're solving systems algebraically, you can use substitution or elimination. So we're going to kind of apply those same ideas for today. One of the first things that I want you to notice is that the variable y is isolated here in this first equation. So I'm going to go ahead and replace its value, which is x squared plus 8x plus 9, into the other equation. So again, the y is isolated, so I'm going to replace its value into the other equation. All right, so I'm going to go ahead and substitute. Instead of y, I'm going to leave a space for the value of y. Remember, that's x squared plus 8x plus 9. I like to copy the whole equation before I substitute. That way I don't leave anything out. That's actually a common mistake I see often when people use substitution. They leave things out of the equation. So again, if you're going to substitute something in for y, put parentheses in its place, but finish copying the whole equation before you actually do the substitution. So remember that y equals x squared plus 8x plus 9. Since there was no coefficient in front of the y, I don't have to distribute anything except for really a 1. But remember, when you multiply something by 1, everything stays the same. So I'm going to go ahead and just distribute and combine like terms. And then I see that this is a quadratic equation, not a linear equation. So with quadratics, you want all your terms on one side, especially if it's standard form. So I'm going to go ahead and move the 3 over. And I have x squared plus 7x minus, hold on, I just realized it was plus 9. Okay, so plus 9 minus 3, so that's going to be plus 6. Okay, so because this is a quadratic with a leading coefficient of 1, I'm going to go ahead and try to factor this. So I need two numbers that multiply to 6 and add to 7. The numbers that'll work are 1 and 6. Again, since the leading coefficient is 1, there's no need to split the middle term. I can just factor this as x plus 1 and x plus 6. So the two solutions are x equals -1 and x equals -6. However, those are just the solutions for x. Okay, the system had two variables. We had x and y. So essentially, all these solutions, there could be one or more, you have to write them as ordered pairs, okay, because they gave you two variables, x and y. So here's the thing. We got two answers for x. So now what we need to do is we need to figure out what our answers for y are if I plug those back into any of the original equations. I personally feel that the easier equation is this one. I always say look for the equation that looks easier. So I'm going to go ahead and take my two answers and I'm going to substitute them into that equation for x and find the corresponding y values. Remember, we just found the value of x, so replace the x's with the values you found. Well, the first value was -1. Oopsies, I don't know, I put an equal sign there. So y minus x, both of these. Remember, like I said, I like to write the whole equation first before I substitute. That's just my personal choice. Okay, and then I plug in a -1 and a -6. Clean it up, this becomes a +1. and then subtract the 1, you get a value of 2. So the partner for when I substituted, and actually let me draw these arrows separate. When I substituted x of -1, I got an answer of y equals 2. So one of my solutions, I'm going to make a little box here. So one of my solutions is -1 comma 2. So when I substituted -1, I got an answer of 2. When I substituted -6, did you finish the algebra on this? Give yourself a minute to do so if you haven't. Subtract the 6, you get -3. So when I substituted -6, remember that you have to write them in order, alphabetical order, x before y. Okay, so there's 2 solutions there. Remember, you can always pause and rewind the video as needed. So as I take a look at this next one, example 2, I notice that these have both the same exponents. The is squared, the x is squared, y is squared, x is squared. That's when you start getting into the conics, when both variables are squared. So if you want to test yourself and prep yourself for your upcoming test, you can ask yourself, what shapes are those? Is it a circle, ellipse, hyperbola, or parabola? Okay, so because they have the same variables and the same exponents, and they're also kind of already lined up, they won't always be, but if you notice ever that they have the same variables, same exponents, you can use elimination. So what I can tell from here is that I can cancel either the y's or the x's. Now, you're allowed to use multiplication to obtain the same coefficients. So I'm just going to worry about canceling the y's. Okay, so I'm just going to focus. So this is like elimination. Remember, you practiced elimination yesterday in your pre-lesson. So right now I have a -2 as a coefficient and a +1. I want them to be opposites. So if I multiply this by +2, and remember, if you change one part of the equation, you got to change every term to keep the balance in the teeter-totter seesaw, right? In an equation, you got to keep the balance on both sides. So I'm going to keep the equation the same for the top, but I wanted opposites, which is now what I have when I distribute the 2. So now I have 2y squared. Now I'm going to distribute 2 times 2x squared and 2 times 54. With elimination, as soon as you obtain opposites, you can add the equations and eliminate the opposites. So I'm going to add everything that's left over. I've got 1x squared plus 4x squared, that's 5x squared, and 17 plus 108, so that's 125. Now this is a quadratic equation. You can set this equal to 0 if you want, but I noticed that there's no linear term. And when there's no linear term, I personally feel that SADMAP is a lot easier to use in solving than quadratic formula or trying to factor. So the objective of SADMAP is for you to get the variable by itself. So right now the variable is being multiplied by 5. So if I divide by 5, I get x squared equals 25. Then I square root both sides. And remember, when you square root while solving, you're going to have a plus or minus when you square root a positive. So there's 2 answers here. So kind of the same scenario as before. Our job is to find the solutions, which are ordered pairs, right, of x and y values. So what we've got here is that we've got a scenario where we've got 2 possible x's. So pick whatever equation looks the easiest. Doesn't matter which one you pick. And plug in a 5 the first time for x and the second time a -5. So again, remember this means that there's two options. Okay, so you can pick any of the original equations. You can pick the one from the top that says negative, um, right here, -2y squared plus x squared equals 17, or you can pick y squared plus 2x squared equals 54. I tend to pick the ones that don't have a lot of negatives, so I'm actually going to substitute into the second equation. For the x value, I'm going to substitute a -5. So right now we're plugging in x values. Okay. Yikes, the highlighter made it a little hard to see. Okay. And then you just pretty much solve for y. Order of operations, guys, don't forget, you need to find out what -5 squared is first. So that's 25. And 25 times 2 is 50. A lot of algebra here, guys. Do you see? Tons and tons of algebra skills we're using here. Then you want to solve for y. So cancel addition and subtraction. There's no linear term here. When there's no linear term, you don't have to factor. Okay, so I'm using SADMAP again. Okay, so I get y squared equals 4. But look, we actually end up having two solutions again. We've got plus or minus 2. So we need to remember that, because as I start to make a list of my solutions, I already said, hey, one of the x values was -5, but we just found out that -5, so I'm just looking over here, okay, as I start to think of my answers. So -5 has two possible y values. It could be a +2 or a -2. So we've already got two solutions from there. Okay, now I'm going to repeat the steps. With a 5, but hopefully you start to see, like, wait a minute, 5 squared is 25. So we're just kind of like repeating. This looks like way too similar to this, right? Isn't it the exact same? Yes. So essentially, you don't even really need to finish this, because you already know that the answers are going to be plus or minus 2. Okay. Sorry, I shouldn't have crossed that out. I'm just saying that you don't have to do all the work. All right. So what does that mean? That means that when I write out the solutions for +5, remember, x was also +5, I need to write that. Look at all these solutions. So I've got 5 that can go with 2 or 5 with -2. Excuse the screaming child in the background, guys. Okay. So again, lots and lots and lots of algebra. Okay. As always, if you need any extra help, make sure you reach out, and we'll be happy to help you. Okay. Have a great day, guys.